Diffusion. We are going to discuss a topic of diffusion. Diffusion and effusion from the state of matter. ठीक है? Diffusion, when two or more non-reacting gases. Diffusion, when two or more non-reacting gases are kept side by side. They have the tendency to mix with one another and form a homogeneous mixture. Homogeneous mixture. This phenomenon can occur even against gravity. This mixing ability of gas is known as diffusion. Now, effusion, it is a process in which gas is allowed to escape under pressure through a fine hole. Gas is allowed to escape under pressure through fine hole. The difference between diffusion and effusion is that latter occurs even when there is no pressure gradient. But this continues to occur as long as pressure is there. Though both processes are essentially the same. Rate of diffusion, it can be defined as the volume or number of moles diffused per unit time. Number of moles of gas diffused per unit time. और ये distance traveled by a gas per unit time through a tube of uniform cross section. ठीक है? अब यहाँ पे आता है ग्राहम्स लॉ ऑफ डिफ्यूजन. कौन सा लॉ आता है? ग्राहम्स लॉ. डिफ्यूजन आने समझ गया हमको क्या है. तो ग्राहम्स लॉ ऑफ डिफ्यूजन क्या बोलता है ये? एट कांस्टेंट pressure and temperature, the rate of diffusion or effusion of gas is inversely proportional to rate of diffusion or effusion is inversely proportional to the root of square root of its density. This is the statement for the Graham's law of diffusion. अब rate of diffusion को कैसे बोलते हैं हम लोग? Rate of diffusion inversely proportional to under root of d. ठीक है. अब R1 अगर हम लेते हैं R1 R2, it present R1 and R2 are the diffusion of two gases, gas 1 or gas 2, and D1 D2 are their density. Then we can write down R1 upon R2 is equal to under root of D2 by D1, है ना. तो हम लोग ये बोल सकते हैं, कि we can run a statement like this: R1 upon R2 is equal to number of moles into temperature, और N1T2, और एक ये भी एक्सप्रेशन होता है N2T1. ठीक है, इस तरह से एक्सप्रेशन हमको मिल रहे हैं. When a gas at pressure P and temperature T is separated from is a separate a gas with temperature, हम लोग बोल सकते हैं जब गैस रहता है एट प्रेशर P एंड टेम्परेचर T is separated from vacuum by a small hole, the rate of escape of its molecule is equal to the rate at which they strike the area of the hole. Therefore, the rate of effusion can be rate of effusion. We can also take the rate of effusion pressure upon twice pi m RT. There is no derivation of this equation, but it is directly proportional to the pressure applied to the gas. ठीक है, अब अपन लेते हैं फैक्टर्स अफेक्टिंग द रेट ऑफ डिफ्यूजन. फैक्टर्स अफेक्टिंग रेट ऑफ डिफ्यूजन. फैक्टर्स जो क्या कर रहे हैं, रेट ऑफ डिफ्यूजन को क्या कर रहे हैं, अफेक्ट कर रहे हैं. सबसे पहला फैक्टर, फैक्टर्स अफेक्टिंग रेट ऑफ डिफ्यूजन. रेट ऑफ डिफ्यूजन फर्स्ट वाला pressure. It is quite logical to understand that the more the partial pressure difference, more will be the rate of diffusion. More partial pressure, more partial pressure difference, more will be rate of diffusion. More will be rate of diffusion. When a gas is kept in a container with the pressure P and placed in an environment where the pressure of the gas is, गैस का प्रेशर है Pg और एनवायरनमेंट का प्रेशर है Pi, then obviously the rate of gas flow should proportional to P gas minus environment pressure. The flow will takes place in a direction of high pressure. फ्लो कहाँ से जाएगा, फ्लो विल बी फ्रॉम हाई टू लो प्रेशर. ठीक है, और दूसरा पॉइंट एरिया. द रेट ऑफ गैस फ्लोज, दूसरा पॉइंट है एरिया. द रेट ऑफ गैस फ्लो should be directly related to the area of the orifice. Greater the orifice area, greater should be the number of molecules, and it is depends totally on the area. 3. Molar mass. Heavier the gas, slower should be heavier. Heavier the gas, slower should be its movement. Heavier the gas, slower the movement. और ले सकते हैं टेम्परेचर. इट वुड हैव बीन एक्सपेक्टेड दैट temperature increases should have increased the rate of gas flow from a container. This follows because increase of gas temperature would increase the energy of the molecule of the gas, energy of molecule of gas. But it should be noted that when a gas molecules move out of a container through a small hole, it is required to move in a very restricted path to be able to come out of the hole. Increase in temperature no doubt increase the velocity, है ना. Increase in temperature increases velocity, increases velocity, but it would also hamper the ability of the molecule to orient itself properly. If the hole is large, है ना, hole is large, rate of diffusion will be more, as the orientation would not matter much for effusion to takes place. Though some factors are affecting the diffusion and the effusion. The radius of the hole R1 upon R2 is equal to under root of, इसको ले सकते हैं हम लोग, if temperature of two gases are T1 and T2 at constant pressure, then we can write R1 upon R2 is equal to under root of M2 upon M1 into T1 upon T2. ठीक है. अब इसमें अपने को आता है कि if container has a hydrogen and oxygen gas mixture, find out the ratio, है ना, find out the rate of diffusion of one gas and rate of diffusion of other gas. ये मोलर मास और ये टेम्परेचर. अपने को आया अगर if problem, if a container has hydrogen and oxygen gas, मिक्सचर है दोनों का, ठीक है, दोनों का मिक्सचर ऑफ हाइड्रोजन एंड ऑक्सीजन गैस. They coming out through the pinhole. These gas coming out through pinhole. Find out the ratio of rate of H2 and O2. Ratio of rate of H2 and O2. ठीक है. तो रेशियो ऑफ H2 अपॉन रेशियो O2 इज इक्वल टू molar mass of O2 upon molar mass of H2. That's equal to 32 divided by 2. That's equal to under root 16. मतलब 4:1. रेशियो इज 4:1. किसका रेशियो है ये? जब गैस कंटेनर से बाहर जा रहा था तब का रेशियो, है ना. दूसरा एक और इक्वेशन ले सकते हैं हम लोग, और दूसरा एक कर सकते हैं. If from pinhole, if from pinhole hydrogen and oxygen are coming out, if in 20 minutes 50 ml of H2 is coming out, find out volume, find out volume of O2 coming out in 5 minutes. Coming out in 5 minutes. देखो टाइम ड्यूरेशन है तुम्हारा डेल्टा टी इज इक्वल टू 20 एंड चेंज इन वॉल्यूम है 50 ml टू मिनट्स. तो रेट इज इक्वल टू होता है डेल्टा वी अपॉन डेल्टा टी, दैट इज इक्वल टू वॉल्यूम चेंज एंड टाइम इंटरवल. तो 50 अपॉन 20 दैट्स इक्वल टू 2.5. We know that R1 upon R2 is equal to under root of M1 upon M2. तो हम लोग लिख सकते हैं यहाँ पे R H2 upon R O2 is equal to MO2 upon M H2. 2.5 upon RO2 is equal to 32 upon 2. तो RO2 is equal to 2.5 upon 4. O2 is equal to delta V upon T 2.5 upon 4. ठीक है. तो अपने को यहाँ पे एक ए मिल रहा है 2.5 अपॉन 4 इज इक्वल टू डेल्टा वी अपॉन 5. तो डेल्टा वी इज इक्वल टू 3 ml. This is the volume of O2 coming out in 5 minutes. Volume of O2 coming out in 5 minutes. एक देखते हैं और a container has a oxygen gas. Container has oxygen gas and sulfur vapors. If rate of effusion of O2 is 2 times faster than the rate of sulfur vapor. Find out the formula of the sulfur vapors. What's formula? Formula of sulfur vapors. तो rate of effusion of R and SX is equal to molar mass divided by 32. That's equal to 2. M upon 32 is equal to 4. So M is equal to 32 into 4. One sulfur is having weight 32. So formula is S4. Formula is S4. Formula of sulfur is S4.